So still continuing with lightly, I ended up posting some of this code and whatever it is that I was doing uh, onto LinkedIn, and there were certain queries over there. So I understand that if you end up posting some code and some video, people would usually want to understand what exactly is happening and why a certain. So there's Brian Hart. He says, "Can you summarize what this alternate approach is doing and the results? I would want to know this before investing time watching a long video." So he's correct. You shouldn't you shouldn't watch the video if you really don't understand as to what it is and why it is being done. So I've gone ahead and I just kind of posted quickly. This was way early in my morning. I actually just posted this from my mobile. So what I'm saying is alternate approach is supposed to extract better features. And here itself, somebody should question me. So, what exactly is better features? What do we mean by better features? So, I myself don't have the definition as of now of better features. And because I don't have the definition of better features, I thought that that lightly code was failing. Yeah. So, what is happening over here? In the end, I'm not getting good, nearest neighbor plots and everything. And that is the reason I thought that maybe this one second, I will have to. Yeah. So maybe because of that, I thought that this slightly code was failing. In data sets and output there, uh, this is what I had right earlier. So this was the first attempt. And in the first attempt, if you look at this, this is supposed to be the example image and you're supposed to get nearest neighbors of that particular image. So this one over here, serial number one is supposed to be the nearest image to this. So it is supposed to be um, some image of the same person, right? But that is not happening. And similarly, you see all of these are failing. As far as I'm concerned, all of these failed. And this happened with the lightly code. This happened with the lightly SimSiam Siamese network code, right? So either I messed up something over there. So this is their first initial this thing which plots the distances, the scatter plot, and this is their code, right? So either I messed up, or these images uh, are a difficult set for this particular code example, um, or maybe my GPU is rotten, and because my GPU is rotten. Um, yeah, this is what I have as my GPU. So I've shared this earlier also. Maybe my GPU is useless and it is not good enough for the lightly code, not good enough for the SimSiam model. So those are the thoughts that I had in mind, and because of those thoughts, I have gone ahead and I have then created the separate code over here and started exploring as to how I can possibly one second. No, where did that go? Yeah. So, how can I possibly end up bettering that feature extraction? So, can I do a better feature extraction, or can I do something, which will better that situation? And that is the reason I have started with this kNN not lightly. Okay. So, it very clearly says kNN not lightly. So where am I getting this? I obviously did not sit and code all of this myself. So I got it from this book, Practical Deep Learning. I have given it right on top over here, book and the source code. Yeah. So again, I had coded some of this long back, almost like I think about a year back or year and a half back, and it had been lying on my system for quite a while. So I don't exactly follow their code now. So over here also, I'm not exactly, even though I've given their links, but I'm not following their code. Some of their code is here, right? So what they have done is slightly different, and I want to do this. I ultimately want to do these benchmarks and all, and it is required. Agreed. But right now, I'm not doing that. So right now, with this very simple TensorFlow code, what I'm trying to achieve is that one is okay. Model picker I have picked up from their code, fine. So to see the flow and understand the flow, we'll go down here. So within the main, this is what I have. So the model for now is Resnet. So model architecture type is Resnet. This goes to the model picker, and Resnet50 is the backbone, if I remember correctly. And this is nothing. This is just giving my GPU stats and putting some minute now, date now, all of this for some reason. So I'm not using this minute now. I should actually be using minute now. I'm using hour now, but that is okay. Doesn't really matter. For now, I probably end up running it in an hour's time or something. So then this is my root directory. What exactly is my root directory? I'm basically putting my input images over here, right? So this is my root directory within datasets. Datasets input their images, kNN images, input their images, kNN images, faces one, and I've got I think about 435 images over here. Okay, and all of this I'm printing out over here. If I go right to the top and I say 435, huh, you will see it printed a couple of places, right? So I'm just printing it all over here. This is my log file. So anybody who wants to follow along can very easily follow along and can understand what exactly is happening. I myself come back someday and I start seeing what is happening. I might end up confusing things. I don't want that. So I always maintain a log file. Now, from within that root directory, I'm doing some splits. I'm getting some names and all that. They're not really that relevant right now. So then I get file names. I wanted to pickle this, get a list of file names and pickle them, and then write them to the uh, persist them on the disk, and then go to different file directories and keep on doing that. But I'm not doing that. It's not that complex right now. Maybe later on I'll do that. So for now I'm not doing that. So then you just get a list of file names, and that list of file names is again how many files? 435. Then you go and extract features from that list of file names. You've gone ahead and you've taken that model architecture type and string constant and all, doesn't matter right now. You go and extract features. So that is this um, get image to vector. We're extracting features from here. So this um, okay, extract features, and now where exactly is this extract features? This is up here. And how these features are getting extracted, let's quickly go through that. So input shape is there. That is a constant I have kept for all images, standard this thing. Width, height, and channel. Then okay, loading images using TF image. Um, then pre-process input. Where is pre-process input coming from? Yeah. So this is coming from KERAS applications Resnet50. So this is specifically for Resnet50. Uh, I'm not sure how this is working, but if I change the model, because okay, right now I've got Resnet, that is okay. But if I change the model, then uh, is it something which is Resnet specific but works otherwise? I'm not sure. I'll need to check this. Yeah. So then we are getting a prediction from that model. We are getting a prediction. So for that pre-processed image, we pass it that pre-processed image and we get a prediction of features. So how are we getting this prediction of features? We've gone ahead and dropped the top layers of the model, and we are using it as a feature extractor in place of using it as a. So I have mentioned that over here somewhere. I say CNN something and I CNN KERAS. So feature extracted and then image classifier. So the image classifier we have dropped. Okay, when we say include top false, what that basically means is we are dropping the image classifier. Okay, here we are saying include top false, include top false. So we are dropping the image classifier. We are using just the feature extractor. Okay, and this can be seen over here. I've given one link over here. You can have a look over here if you want to. So fine. With after having done all of this, where did we go? Okay, yeah. So you're getting features, and with those features, uh, over here I've changed the number now. I've gone to 10. Earlier this was just 5, so we were getting a low number of neighbors. Now I've gone to 10, and further somewhere, which is over here, like I've kept a to do over here on top. Uh, I'm again restricting that within the code, and actually getting only 7 neighbors. So the overall cap is at 10, but ultimately getting only 7 neighbors. Now this is working quite well. I thought there were issues with the sorry, I've just uploaded this. Let me first show you the results and then run it again, because things can go wrong in a. So this is the input directory. Then coming here, this is the output directory. Within output directory, this is something which was at 8 o'clock. Right now it's just it's around 11:30. So this is the other one, and this got created about 10-15 minutes back. Yeah, so this is the one we'll look at, and this is a directory being created by the R. So just a very basic Python timestamp being used to create the directory. And now look at this is for image 001. Now what exactly is image 001? To have a look, see, we can just compare input directory, images, kNN images, faces 1, and image 001. So image 001 is this. You see 3 books in the background. You see some kind of other books and material over there, and you see this person's face. So this is image 001. Going here, what is image 001? This is image 01, the same one. And then what is 2? 2 is probably the one which is most similar to 1. I'll again check within the code. I haven't done the plots yet. So that is 2. Then is this, and then is 367. Okay. So if I were to look at image underscore 001 within the log file, this should be image. Okay. Yeah. So this is what we are looking at, and there are 80 occurrences. I'm not interested in these 80 occurrences actually. Okay, yeah. So let's look at this. Where does it say plot? So it says initial query image 1, and it says image 001, and how many occurrences are there? 14 occurrences are there. Okay, so 14 instances where I've gone ahead and looked at image 001, and within this directory, this is the query image directory path. Okay, sorry. Again, 14 occurrences, and within these 14 occurrences you can see these other images which it is gone and said are similar images. So right below this line, let's say line 18,884 85 line, you have the image 367, then you have image 2, then 172. So if you go here, you look at 367, you look at 172, you look at 157. So this is the code basically, and if I were to again try and see for this image 367, there are many occurrences. One second. I basically want to one second. The code is not very well organized right now, so this will be slightly weird. Let's go to the top and then maybe from there onwards. So okay, so it is giving similar image paths, and how many image paths is it giving? 7 of them, and it is giving you distances. Okay, so for now, I will have to organize this slightly better if I have to explain it in this manner. But what I really want to do is I want to plot these distances on that, on a PDF plot, a similar plot, the kind of plot that we have where, mm, the kind of plot that we have here. Okay, so if I get this plot and it says example image 3, so I want image 1 to be plotted, image to be shown, and right next to this it should show the distance measure. So you can understand that what is the difference, what is the distance which is being measured, and also the different kind of distances. So once that is done, uh, then it will be much better to read through these plots. But for now, I'll just quickly go through some of these and we can have a look. So this is image 1. Similarly, for image 2, what is image 2? This is image 2. Okay, over here, I think we're getting much better results than the earlier one, but still not that good. Let's randomly look at something. Maybe image 40. I don't know, image 25. Okay, here we are definitely getting better results. Yeah, because out of all 7, only one is of another individual. Rest all are similar, are of the same individual. So here extraction has happened better. Then you could probably end up trying to understand why in certain images the extraction is better versus in others. Here again, you see this lady's images dominate, out of the 7, and there are only 3 of them which are different. So 4 are hers and 3 are different. So again, this seems to be doing a much better job than what was happening with the SimCM. So again, those same questions need to be answered, and it will be answered over here. Uh, and for now, within this particular branch, uh, I will keep these, uh, you know, I will keep these images there only. Within the output there, I am not going to delete this, because in case somebody wants to have a look, you can have a look over here. Uh, I put this path somewhere. Okay, so I think that's about it for now, and little bit more structuring of outputs, that is what is required, and also uh, some tables which can give a tabular result, so we can end up comparing things. Yeah.